Hey everyone, and welcome to The Explainer. I am so thrilled you're joining me today because we are going to embark on a massive, totally mind-bending thought experiment. We usually just think of oxygen as that invisible stuff we need to breathe, right? We kind of take it for granted. But today, we're going to look at the true, hidden role of oxygen on Earth, and we're going to do it by imagining what would actually happen if it just vanished.
So right now, literally right this second, I want you to take a deep breath. Go on, really take a huge one. Okay, now imagine that the oxygen you just inhaled disappears completely from the entire universe. Not forever, but for exactly 5 seconds. Honestly, it sounds relatively harmless, doesn't it? I mean, most of us could easily hold our breath in a swimming pool for way longer than that. You probably wouldn't even notice a change in your own breathing. But while your body could hold its breath, I promise you, the material world around you absolutely cannot.
Okay, let's dive into this. We're putting 5 seconds on the clock, and we are kicking off a rapid-fire global catastrophe. Let's start the clock. Second 1.
Boom! The very first consequence is completely silent but instantaneous. All combustion stops worldwide. You see, combustion is fundamentally an oxidation reaction. Whether we're talking about a tiny candle, a raging forest fire, or a massive jet engine cruising at 40,000 feet, they all require molecular oxygen as an oxidizing agent. You take away the oxygen, and you instantly take away the chemical pathway. In under 1 single second, every flame extinguishes. Coal and gas power plants stop generating electricity. Jet engines flame out in the sky. Every single car and motorcycle engine just stalls out because there is literally no oxygen to ignite the fuel. The whole world loses its power, instantly.
Okay, moving into second 2, and this is where things get violently physical. Oxygen makes up about 21% of our atmosphere's volume. If you suddenly remove it, the atmospheric pressure drops roughly 21% in a fraction of a second. We'd plunge from a normal pressure of over 101,000 pascals down to around 80,000. Physically speaking, that is the exact same as suddenly teleporting from sea level to an altitude of 6,000 meters. That is approaching the height of Mount Everest Base Camp in the blink of an eye. And your body simply cannot adapt to a pressure drop that fast. Your tympanic membrane, your eardrum, is flexible, sure, but it is designed for gradual changes. With a sudden 21% pressure drop, the air pressure inside your middle ear remains normal for a split second, while the outside pressure completely collapses. The result? Severe barotrauma. The membrane just bursts outward. Billions of eardrums worldwide would rupture in a single instant, causing absolute planet-wide vertigo and severe biological shock.
By the 3rd second, the horror becomes incredibly visual. The sky above you turns black. Why? Well, the sky appears blue to us because of something called Rayleigh scattering. That's where oxygen and nitrogen molecules scatter the sun's shorter visible light wavelength. If you instantly strip away 21% of all the atmospheric molecules, the scattering intensity drops massively. The sky would instantly shift from that comforting bright blue to a terrifying deep violet black. The sun would just look like this harsh, piercing star sitting against a dark, empty void.
And this brilliantly illustrates our next terrifying reality. Because it's not just the sky, it's literally the ground beneath our feet. Geological data revealing the composition of the Earth's crust holds a massive, massive surprise for what takes the #1 spot.
Look at this, it's staggering. Oxygen makes up 46.4% of the Earth's crust. It's bonded right there with silicon, aluminum, and iron. Oxygen is literally the ground we walk on. Without it, the chemical bonds holding the crust together just vanish. The solid rock, the soil, the earth beneath us would simply crumble into dust. The ground would collapse entirely, sending everything and everyone into a terrifying freefall.
And hey, the built environment, it fares no better. Without the protective layer of oxidation that naturally forms on metals, untreated metals would instantly weld together the second they touch. And concrete? Portland cement relies heavily on oxygen-bonded compounds. Oxygen essentially acts as its special binding agent. Without it, monumental structures like the Hoover Dam or the Pantheon Dome wouldn't just crack, they would instantaneously disintegrate into dust. The man-made world would literally fall apart.
Right, now we hit seconds 4 and 5, and a micro-level biological shock is happening simultaneously inside you. Your mitochondria use oxygen to produce ATP, which is basically the energy molecule for your cells. Without oxygen, the electron transport chain backs up entirely. Your energy production hits absolute zero. And here is the scariest part, your neurons, your brain cells, hit their irreversible damage threshold right around 4 to 6 seconds. Right at our 5-second mark, our brain cells are literally teetering on the brink of death.
Section 2. How Earth Got Oxygen, a Geological Flashback.
Let's just hit pause on that ticking clock right at the 5-second mark. Take an imaginary breath. To really understand why losing oxygen is so instantly fatal to our planet, we need a quick look at how we became so completely, totally dependent on this highly electronegative element in the first place.
You see, Earth wasn't always like this. In its early days, the prebiotic atmosphere had virtually zero oxygen. None. But around 2.45 billion years ago, these tiny cyanobacteria started producing oxygen through photosynthesis, which triggered the Great Oxygenation Event. This event literally rusted the iron in the oceans, wiped out a ton of anaerobic life, and built our ozone layer. Then, after a super long period geologists playfully called the Boring Billion, a second surge, the Neoproterozoic oxygenation event, pushed oxygen levels even higher. Oxygen painstakingly transformed Earth from a toxic, anoxic rock into the vibrant, rust-filled, ozone-shielded planet we know and love today.
It took literally billions of years of incredibly complex biogeochemical cycles to reach our modern atmospheric concentration of 21%. Every piece of infrastructure, every ecosystem, and every single cell in our bodies evolved based on this exact chemical reality, which perfectly sets the stage for the catastrophic climax of our 5-second thought experiment. Section 3. The explosive return, when oxygen comes back. Okay, the 5 seconds are up. Our time is over. The oxygen rushes back. Now you might be thinking, "Phew, this is the moment we're saved." But actually, the return of oxygen might be vastly more destructive than its disappearance. So, the crucial point is understanding the fire triangle: fuel, oxygen, and heat. During those 5 seconds without oxygen, all those engines and massive industrial plants didn't just disappear, right? They kept pumping unburned kerosene and natural gas into their systems because the fuel suddenly had nowhere to burn. So you have these massive, terrifying accumulations of unburned, vaporized fuel just sitting everywhere. Then, bam, oxygen suddenly returns to 21%. And the engines and furnaces, well, they're still blazing hot, which provides the absolute perfect ignition spark.
The result? A planet-wide simultaneous ignition. The sudden reintroduction of oxygen acts as a massive global trigger. Every stalled jet engine in the sky detonates in a colossal backfire. Industrial facilities filled with vaporized fuel just explode. Power plants experience catastrophic combustion surges. Literally every engine on Earth detonates at the exact same moment. The second disaster begins the absolute millisecond the first one ends.
And that, my friends, brings us to the resolution of our thought experiment. We survived the 5 seconds, sure, but the world didn't. Oxygen is not just a component of the air. It is the oxidizing backbone of energy, structure, and life. It's the silent, invisible architect that spent billions of years painstakingly crafting the chemistry of literally everything around us, from the concrete in our modern cities to the warm blood pumping in our veins.
It is truly mind-blowing when you break it all down like this. So, I want to leave you with this final provocative thought. Next time you take a deep breath, are you just inhaling empty air, or are you pulling in the invisible molecule that is quite literally holding our entire world together? Seriously, just look around the room right now. Look at the walls, the glass, the metals, and maybe have a newfound respect for the crazy chemistry you previously completely took for granted. Thanks so much for exploring this with me on The Explainer today. Stay curious, keep learning, and I'll catch you on the next one.